Yo, I'm gonna fix my microphone. Yo, what is up, guys? Sorry. Yeah, fix my microphone. Yeah, what's up, guys? Welcome back. Another day, another episode. I think the goal today, we have one more episode left in the OpenGL series for batch rendering. And I think that's kind of what we're going to look at today. Let's take a look here. Let's see the full playlist. You want to take a look at the last one here. So I think we finished on these two yesterday. And I kind of watched these two in my own time, kind of implemented what I needed to do. And I think what we're going to do today is we're going to take a look at the batch running for geometry. I don't know if maybe I started it a little bit, and honestly I can't really remember. I don't think I did, but this will be the last episode, and then we're going to be starting the game engine series here on probably tomorrow. Sunday tomorrow, so probably architecting out the game engine, kind of how laid out, how we're gonna kind of how we're gonna do it, and what's gonna be included. It's gonna be a simple engine, then we're gonna kind of build a game from there. So I think that's the goal. But yeah, we're gonna take a look at the problem of the day that I missed yesterday. Which I believe is one back. Yeah, so 2872 maximum number of k divisible components. It's always k divisible. Given an undirected tree with n nodes labeled from 0 to n-1, you're given the integer n and a 2D array edges of length n-1, where edges I is equal to ai bi. Indicates that there is an edge between nodes a1 and b1 in the tree. You're also given a 0-index integer array values of length n, where values I is the value associated with the ith node, and an integer k. Valid split of the tree is obtained by removing any set of edges, possibly empty, from the tree, such that the resulting components. A valid split of the tree is obtained by removing any set of edges, possibly empty, from the tree, such that the resulting components all have values that are divisible by k. Interesting. So I believe let's see here. I believe here from... Sorry, I'm just trying to open everything. Let's open Spotify here. Let's play some music. Alright, so I'm thinking this is probably just a regular DFS. Hey bro, I hope you're good. What's up, No Tech Noble? What's up? Good to see you again, bro. Yeah, I'm good, man. Just building and you know, doing the daily Leetcode. I mean, that's kind of what I start with every day. So let's take a look here. Length edges n-1. Edges I dot length is equal to 2. Sum of values is divisible by k. The input is generated. The edge is represented in a valid tree. So I think the goal is here is we're gonna have to build an adjacency list from here. So let's come over here. Right, this is what we're given. We're given these edges here, right? We have to somehow map these edges here to our values, right? So these are our values here. So I think these are the values for each node here. I burnt the top of my tongue as well, bro. Oh my gosh, dude. Kind of hurts. Yeah, retrieve starts at 0. So I think it is a DFS, honestly. I'm just going to confirm here that these are the values here of the tree. Because it doesn't really match in these photos here. Like here it has 1, 2, 3, 4, 0. You know, I can see why we have 0, 2, right? This edge, right? Edges 1, 2, this edge, right? 1, 3, this edge. 2, 4, this edge, right? But shouldn't the values be... I don't know. I guess I'm just trying to confirm that really, but... of each node. I don't know, I'm low-key kind of bored. What's up, bro? What's up, Alifan? Hi, what's up, guys? Appreciate you guys joining. Let's look at some... have you studied programming languages? Yeah, I have. Yeah. I did that in my undergrad, yeah. Just trying to make sure. I think we have to create an adjacency list here. Okay, so the values are each index corresponds to a node, okay, and the numbers of values stored at that node. Okay, so yeah, okay, that's what I thought. Okay, I just wanted to make sure. Working on putting textures onto a circle. Did you learn it already in the Cheno's tutorial? Yeah, I did, bro. Yeah, I think the goal is today I did a little bit more last night. Well, you're probably up to this video, right? I would assume. Yeah, I'm up to the final one here. So I kind of refactored my stuff, but we're kind of getting there in the end. So finally going to learn about dynamic geometry, which so far we've been learning about static geometry and obviously, you know, batch rendering. So, you know, batching multiple squares on the screen into one draw call, right? And then obviously these videos specific go into like, you know, changing the colors, right, in each thing, and then changing the textures, right? Like, so I assume this dynamic geometry might be something to do with like maybe, you know, rendering different shapes or something within one draw call. I don't know. I guess we'll see in the video. I've obviously watched a little bit, but I think it was a little while ago. I just took a look at it, but yeah, it's been good, man. And then I plan to do 2D game engine. So yeah, that's the goal. Programming language Go? No, I usually do C++. That's kind of my thing. I've never actually done anything in Go before, so yeah. Okay, let's kind of get started here, right? So we probably want to make let's think here, probably some sort of hash map here. So let's kind of create that, right? So we can do a unordered map. Took your advice and been solving Leetcode and Eco daily, and it's changed and helped with my thinking, solving problems a lot. There you go, bro. Type shit. That's the way you want to do it. Just working at it every day, bro. That's how you make it. 2D game engine. Wow, poggers. Yeah, dude. That's kind of, I believe, what I'm kind of gonna go to. Loki, making an Atari breakout seems like a good project to learn alongside bouncing ball one, but I will do that much later. I think that's a good idea too. I'm just like really interested in a 2D game engine. I know he has a 2D game engine series, but I think maybe the project is a little bit ambitious, but I think the goal is to that's kind of what I want to start at. I'm gonna kind of think about it tomorrow and kind of think about exactly what I want inside of the 2D game engine. I think I'm gonna make enough where I can build a game from it, so that's kind of the goal. And I think I'll learn a lot along the way. I think I'll struggle a lot. I think I'll have to watch a lot of videos. I think I'll have to, you know, do a lot of different things, but that's kind of where I kind of want to bring my knowledge and kind of build something like that. So, okay, so we want an unordered map here. We probably want a vector of integers here, right, to store. Let's call this our adjacency list, right? Let's create a function here, right? We can call it void create adjacency list, right? We can create the adjacency list here. We can pass in. So we got int n. So we got 5 nodes. 1, 2, 3, 4. That makes sense. 1, 2, 3, 4, 5, and then we got k is equal to 6, right? So probably what we want here is we probably want int n. We probably want our vector of integers. Right now, we're going to build the adjacency list, and I think we're going to move forward, but I think the goal I'm going to have, I am pretty confident this is some sort of DFS traversal here. So we have these values here. Come down here. Come down here. 2, 1. So obviously I'm thinking about some sort of backtracking DFS approach here, where we kind of begin, obviously, at the first node, right? As we kind of loop, right? We come all the way down, right? DFS comes all the way down here, right? We take this value here and we kind of build up, right? And the values that we build up here, I'm thinking that, you know, maybe we can find all the subsets here. I don't know if I'm interpreting the problem right, but maybe we can find some sort of subsets here as we build back up the subgraph, right? So I think that's kind of the goal for this problem. I don't know. 2D game engine is ambitious. Yes, sir. Yeah, it definitely is, but I think I have the ability and the knowledge to do it. Especially, you know, if I lay out my features correctly, exactly what I want. You know, this is not going to be anything incredible, anything massive, but, you know, I think I can kind of watch videos and put stuff together and kind of work on it. So I guess that's the goal about learning, right? You got to be a little bit ambitious, I guess. So, and then, you know, I plan to probably go do something in 3D or something, but I think having a good foundation of 2D, you know, rendering and 2D, you know, 2D stuff is a great foundation to then move to 3D, obviously. But anyway, so let's call this method here. We'll pass in m. We want n. We want our edges and we want our values, right? Let's grab our vector of integers, reference edges. We want a vector of integers, reference values. Okay, here we want to build the adjacency list, right? So let's go ahead and do that. We probably want to go. How do we want to do this? I'm thinking I've built so many adjacency lists in the past. I literally just haven't built one in a while. I guess from node 0, right? From the specific node, right, we want the ability to, you know, move, I guess, right? We just want, in our values array, we want where we can move to, right? I feel like that's probably the goal. So I'm trying to think how we want to do that exactly. So where we're given here, we're given edge A, or A and B, and we connect this edge. So 0 is connected to 1, right? 0 is connected to 2. So guess we'd have to go, well, for auto reference edge in edges, right? We want edge. So let's do, these are all integers here, so we can do like int A is equal to edge 0, right? And int B is equal to edge 1. I guess here what we could do is we could return, instead of having this down here, we could actually return this, right? So what we could do here is then we could create the unordered map. Alright, the adjacency list here. Get rid of this, right? We can maybe have like an int res or something that we can return, right? We have our adjacency list for order reference edge in edges. We can go int a is equal to edge 0, int b is equal to edge 1, right? This is a this is unordered, so I guess, you know, we have no directed edges right in this graph, so we'd probably have to add both edge A and B, right? So I'm trying to think here how we can do this. Let's go trying to think here. Adjacency list. Ow, fuck. Adjacency list. I guess at this point we can have 2, 0, right? 0, 2, but we can also have, you know, we could be at node 0 and move back to 2. Yeah, so I am right. We have to do both, right? So, I guess adjacency list A dot append B, right? Adjacency list B dot append A, right? So we got to add both, since it's not a directed graph. Alright, so we add both here. I guess that's really about it, right? And then we'd probably return, right? Return our adjacency list, right? And then when we call this function, we give it this type here. We call it our adjacency list is equal to this, right? We create our adjacency list, right? Let's get Claude to generate us a print function because I don't want to write it myself. So let's go. Can you generate a print function in C++ for this type? Perfect. Thank you, Claude. Thank you for that. Let's take that value, that over here, create that print function here for me. Thank you, row. Perfect. Right, let's print this, see what it looks like, right? Print for testing. How do we call it? Print, right? So print. What are we passing in? Constant ordered map int vector. Okay, yeah, that's what I want. Let's pass in our adjacency list. Alright. Okay, we need a return type. Returning an int, we can return our res. Append and stood vector int. I think it's push back. Whoops, push back. Let's push that back. Okay, perfect. Take a look at what we got, right? So this is our adjacency list. See if this matches, right? So node 0, 2. I think this is good. I think this works. Just gonna double check that this is the correct way to do this. I believe we did this correct. It kind of makes sense. This is an undirected tree, so yeah, I believe this is good. So that looks good. Print function here. Didn't want to write. Okay, so we've got our adjacency list now, so we know what to work with, right? And when we start our DFS traversal, we want to start from our first node here, right? So that would be n is equal to 0, right? So in this case here, we'd pass in n, which would be 0 here. I've never really done a DFS with... I don't know if I've ever done a DFS with a hash map here, so this would be something new, but... okay. So we have our print for testing. Let's have our DFS function here, so we can call DFS. We can pass in our adjacency list. What else are we going to need? We won't need our edges. We'd probably need n, right? And we'd probably need values, right? So vector of oh, we don't need the type. Whoops. We have our values here, and we have k, right? So let's create our DFS function. So we'll probably return an int here, right? Maybe not. Maybe we'll keep it a void for now. Because maybe this only really needs to be a DFS function, no caching. I think. I don't know. I guess we'll see. We'll kind of think about it, kind of how we got it for now, but void DFS, we pass in integer n, a vector of images. Oh, sorry, no. We want the unordered map int vector of images, an adjacency list. In n, we want our values here, so this needs to be a reference. Whoops. Yeah, reference here. Int n. Values is a vector of int reference values, and then we want our int k. So we have our DFS value here, right? So let's think about it. Like, what would be our base case here? Well, I think we're gonna need one. We're gonna need like a we're gonna need like an out of bounds check, right? Out of bounds check, right? 2, we're gonna need a divisible by k check, right? By k check. I think that's probably what we're gonna need. I'm trying to think about the out of bounds check. I've never really done a DFS on a hash map before, so this is gonna be a little bit interesting. But oh no, I have. That's a lie. I have. I guess we're gonna have to. Now that I think about it, we're probably gonna need like a lot more other things, right? We're gonna need some sort of visited set, right? It's been a while since I've done this, but we're gonna need some sort of visited set, right? So let's create like a unordered set of integers, right? We can call it visited. I'm not 100% sure, but I think we're gonna need some sort of set for the current path. I think from memory. It's probably good. I'm doing a graph problem. It's been a little while, so kind of use that. Because the visited, right, we don't want to, you know, when we're traversing, right, we don't want to go back to the node we've already seen, right? That wouldn't be right. You know, we'd want to get rid of those, right? So we only want to keep progressing when we've seen, haven't seen that value, right? So we'd want to keep progressing down, I guess, in a way. Yeah, I don't know. Maybe unordered set int reference visited. Ordered set int reference path. Okay, out of bounds check. Okay. Let's think about this, right? Out of bounds check, right? How do we want to do an out of bounds check? Well, I feel like the out of bounds check would be checking if the key exists, right? If the key doesn't exist, then we'd probably be out of bounds, right? And every time we move, we'd probably need to update some sort of I that we're at, right? So maybe that might be a good idea to bring that in as well. Maybe we're overthinking the problem, but visited path, right? We could have our I over here. Maybe our I being kind of what we're, the value that we're at, right? So in this case here, this would be a 0. JSON list and values k visited path. These are all passing in everything. So I guess, well, if adjacency list doc, I have to have a look at the unwanted map API, unwanted map documentation. I kind of have a headache, bro, not gonna lie. What is it? Count, right? Yeah, count. Returns the number of elements matching the specific key. Finds elements with a specific key. So I guess if adjacency list count I, right? Right, if this is false, right? Then we would just want to return, right? Because we are technically out of bounds, right? Out of bounds. We need, well, if now we probably need to look at unordered set, right? Unordered set C++ documentation. Bucket count, arrays, insert. Yeah, I gotta text my phone. All right. So we're out of bounds. Here we want to make if visited dot, this is dot count, right? Unordered set, yeah. If visited dot count, I, right? So if it exists, then we want to return as well, right? We need a if oh shit, we need some sort of sum as well, I feel like. Right, we're gonna need like a sum too, because this is about adding, right? In sum. Alright, the sum is gonna be at 0 as well. Okay, let's do like if some percent k is equal to 0, we can return that. No, we'd want to return 0. No, yeah. Trying to think about this, like, this is very difficult, this problem. For adjacency list count. This would have to be an... I'm trying to think here, like, what will we return here? Because if we're looking for subcounts here, we probably want to return... If we find a valid subcount, we'd want to return 0 back up the recursion tree, right? Which means... I think I have the right idea to solve it. I think this is just like a really tough implementation. Like... Let's think about it. Let's take a look at, let's grab our DFS function here. I think I have the right idea, but I'm just not really 100% sure kind of how to implement it off the top of my head. Gonna need a little bit of a hint. Oh my gosh, this is a tree, so we wouldn't need this. But I guess I wouldn't have known that because I feel like we're using adjacency, so it kind of feels more like a graph in a way. So let's get rid of that. Kind of feels like more of a graph problem in a little bit of a way. Which means we can get rid of this visited, yeah. Int DFS. Maybe we wouldn't even need an out of bounds here, right? We're not... I think I'm thinking about it too much, right? Go int sum is equal to... values... Use I for int neighbor in adjacency list. Adjacency list. Shit, what is it? Adjacency list. Fuck. What would this be? The current I. I have to think about this more. So I know we have to loop through every neighbor here, right? We're using an adjacency list. If we're looping through every neighbor here, that means we probably don't need the bounds check, right? Because we're guaranteed that, you know, we're gonna have a find check, right? Maybe as it loops, we can do like some sort of if check here, right? So maybe like, okay, well, if some %k, right, is 0, we can like increase some like, where's plus or equal to 1? I don't know, maybe something like that, right? And return 0 from that, right? I'm just not sure what to do with this sum, right? Should we increment the sum as we go? Or in sum is equal to values I. I guess this is the current node we're looking at. We can go in sum plus or equal to values I. Right? Loop through all our neighbors, right? If the neighbor is equal to I, right? We just continue. Otherwise, we DFS here, right? We DFS from the specific value we're at. So we would go pass in our neighbor, pass in our sum. Sorry, not in sum. Sum plus or equal to values I. Neighbor sum, our adjacency list, and values in our K, right? So we've incremented our sum. Increment our sum, right? Sum plus or equal to values I. Our neighbor in adjacency list I. If the neighbor is I, we obviously don't want to continue that, right? Then it's going to be an infinite loop. We DFS. Whatever we return from this is, at that point, we would check what our sum would be, right? Does that make sense? I don't know. I feel like there's definitely something wrong in that, but I think that's a good way to... I don't know, dude. I'm trying to think. Anyone have any ideas? Anyone who has maybe solved this before? I don't know. I feel like I'm on the right idea, but I'm just not really sure about the implementation. Let's kind of take a look here at the topics here. It is a depth first problem. It surprisingly has a high acceptance rate. The Leetcoding grind is finally paying off. 2 little brain cells. What a dog this guy is, bro. Oh, bro. I wish I could solve in 15 minutes, bro. It's kind of alpha of him, but... Actually, no. This should be... Maybe we don't even need this. What if we don't need that, right? What if we just use I? We do in sum is equal to values I, right? Every single neighbor, we then do our cur sum plus or equal to child. In child is equal to this. Cur sum plus or equal to child. Sum cur sum percent k, we increase, return 0. As we just return our current sum. Increment our sum. Alright, so we make a local variable here, increment our current sum. We loop through our neighbors. If it's the same, we would then return. If the child, we run DFS on this, right? We set that to be equal to the child, right? Because either what the answer is going to be is that it's going to be plus or equal to the current sum that we have, right? The if check here, current sum %k is equal to 0. We know that it's then k divisible, right? We can increase our global counter that we have here, right? Which is down here. We then return 0, right? The reason why we return 0 is because once we have a subgraph that is valid, we can then return 0 to kind of reset that, right? I think that's the right idea to think about it, right? Return 0. Then we have our curve sum here, right? We would return our curve sum, whatever that may be. Right? I think. I don't know. I think we'll just kind of go for it. Whatever. Okay, we got int k. It's not liking this for some reason. Too many arguments to the function call. Okay, we need to get rid of 0. Int curve sum plus or equal to values I. What is happening here? Error invalid plus or equals. Or is this not allowed, bro? What the fuck? Oh shit, this shouldn't even be plus or equals. This should be equals. Whoops. Yeah, this should be equals, right? Then we're adding here. Yeah. Identify a sum. Guess we don't even need sum anymore. Right, we have I, the adjacency list, N, the current values, and the K. Yo, Aaron Yeager. Hi, what's up, bro? Good to see you, man. Appreciate you joining the stream, dude. Runtime error, great. I don't know what the fuck this means. Stack Overflow on address. Okay. Let's do like full order reference neighbor. I don't know if that makes a difference, but probably not, but deadly single. I don't know what that means, dude. What does this mean, dude? Let's figure this out. DFS is revisiting the parent. I have the check here, though. I feel like I'm not allowing that revisiting here. I think that this check is what stops it there. Can you give me an advice? Yes, bro, I can try. I don't have the most amazing advice in the world, but yeah, I can try. Yeah, bro, I can try. What's your question, dude? So apparently what I'm missing here is I need a parent parameter, which is what I missed. So I'm on the right track. So I is the current value that we're looking at, but what I need is a parent parameter. That's what I'm missing. Int parent. So I guess if the neighbor is equal to the parent, we would continue. We pass in our parent here. Current sum, turn current sum. Oh my gosh, dude. DFS, right, we're gonna need to give it an initial value here. I think the initial value here would be 0. We start off at node 0. Yeah, I would think, right? In this case here, would I pass an I, right? I was the old value, right? So I think we pass an I actually here instead of... That would make sense, I feel like. Oh my gosh, dude. No fucking way, bro. There's no way this submits, dude. Oh my gosh, dude. Runtime error, signed integer overflow. Cannot be presented in type int. How can I fix this issue? What does this need to be? Something else? Curve sum plus or equal to child. Bro, dude, this would be crazy that if I solve this. Holy fuck. I guess it's been a little while, but what are we missing here? So what was the error? Fuck. Reading a signed integer overflow doesn't fit inside of an int. So what would it have to be? A long? Hang on, bro. I gotta submit it again. Grab that error. I think it's I think I'm gonna need to change the type to a long, I think. Let's grab this. I think I have to change the curve sum to a long. Do auto. Okay. Well, you think that'll work if I just change it to auto? Curve sum plus or equal to child. Nope. Should I change this to order? I don't know, maybe. Nope. I think I need a long, so it overflows. Okay, so maybe, what if I change this to long? And I change the child to a long, right? And then when I return here, I return this back to an int. Nope. I'm actually just getting a wrong answer this time. Bro, I don't know what the fuck, dude. So I am passing these test cases, I just don't know. Maybe if we make this a long here. A long DFS. We don't have to turn this, and then we can convert here. right? Because technically we're always going to be returning a res here, right? I mean, so I don't think this matters here. I think this is fine here being this. Let's see if that works. Bro, dude, no way, bro. Oh my god, bro. No fucking way, bro. I fucking solved it. Holy fuck. Dude. No fucking way. Wow. That is probably the happiest I've ever been on this website, bro. I'm not even gonna lie. Like, wow. Maybe my Leetcoding is finally paying off, dude. Holy shit, that was crazy. I cannot believe I solved that. There's obviously a faster way to do it, right? But honestly, I don't really give a fuck, to be honest. I mean, completely honest with you. Let's kind of see what these guys did. So they're doing a BFS here, I think. Maybe that is a faster way. What did these guys do? See, probably used on some competitive programming, like nerd stuff, dude. I don't know. How many problems did you solve in Leetcode? Dude, I've solved a lot, bro. I have solved 541. Yeah. Wow, man, I'm really happy I solved that. That was a big time problem, I feel like. Yeah, I've solved 541. I've only really ever solved 17 hard problems, so I haven't really taken a shot at a lot of the hard problems, but you know, I don't know. I usually stick to mediums and easy, so I'm pretty happy about solving that, I guess, considered a hard problem. But yeah, it's pretty dope, dude. I kind of want to see what that problem was rated, actually. Because I had never really done this before. Like, this was a little interesting to me. I kind of originally thought it was a graph problem until I realized that, you know, really we're just using a for loop here and looping through the neighbors, right? So didn't really need all those checks or whatever, but let's kind of see what the discussion says. It's the hard problem. Not able to solve this question. I've lost a lot of confidence after seeing the number of accepted solutions during a contest. Yeah. So a question of contest. Yeah, bro, interesting. Let's see kind of what it was rated as a problem. I'm hoping that it was at least above 1800. So I'm trying to get better. What the fuck? 2872. I still have to do a contest, bro, and I will do a contest eventually. It's just in like, wow, dude, that was 1968 rated. Wow, bro. That was probably the highest rated problem I've ever solved, I think. I would probably say. I usually can't solve stuff that's rated near 2000. Like, I'm pretty happy about that. That was dope. That was cool. Let's take a look at, quickly solve this one here. 3512, minimum operations to make array sum divisible by k. You're given an integer k nums, an integer k. You can perform the following operation any number of times. Select index I, replace nums I with nums I minus 1. Turn the minimum number of operations required to make the sum of the array divisible by k. K is equal to 5. We want to output 4. Make the sum of the array divisible by k. So what do we get here? We get, all right, 3397 k is equal to 5, right? So what do we add this up? This is 12 plus 7, which is 19, right? So we're at 19 here. Perform 4 operations on numbers 1, I. Okay, so right, an operation is we have to take the current number and then minus 1 to it, right? So that's why it's 4, right? We see 19. We need 4, right? I don't know if this is a little bit too easy. I don't know. Maybe this is the solution. I don't know. But what if... Can't you just loop through this, right? We go 3, right? So we have this here, right? And since we know that we can only minus 1 every time, right? When we loop through this here, wouldn't the... Right, we take 3, right? We add our sum. We take 9. We add 9, right? And we add 7, right? Okay, we take 19, right? And then... Well, we would take... Return the minimum number of operations recorded, right? So would we mod that, right? Make array divisible by k. What is our k in this case? 5. So what is 19... Right, we would take 19 mod 5, right? Is that 19 mod 5? 4, right? Yeah, which is 4. And that's what we want to return here. I don't know. I think that's probably the solution, but... Let's see. I plus plus, we just, what? Probably have like a... Getting sum here. 0, we loop through. Plus or equal to nums I, right? And then we take the sum. Hello, Baha, Alani. What's up, bro? Welcome to the stream, dude. Then we go. I guess we can go like int mod is equal to sum mod k. And then we just like return that mod. I think that's the way to go about this, I'm pretty sure. Okay. I think that's the solution, but okay. That was pretty straightforward, but to kind of take a little discussion, the hint gives the answer. I didn't even look at the hint. Okay. Fair enough, yeah. Easiest on easy. People who solved it in one go, kindly upvote. Let's go, bro. Cool, man. Let's kind of see what that was rated. That was probably one of the easiest problems, I think. Maybe that's easier than Tucson, bro. They literally give you the answer in the description. Contest minimum operations 3512. I can't even copy it. 3512. Wow, bro. 1200 rated, man. Crazy that that's a problem. That's 1200 rated. Interesting. Okay, so we're gonna start with Leetcode there. That was a pretty good day. I mean, we solved the nearly pretty much 2,000 rated problems, so that was pretty cool. And then finished the problem of the day. That brings us to a total of 542 problems solved. I still need to do a contest. I want to get a rating, so but yeah, cool. We're gonna take a look at batch rendering today, which is the final episode here of Cherno series, dynamic geometry. We've kind of come a long way. I guess I'll kind of show it on the stream for our rendering stuff. We got all these different tests, right? I mean, we can change the color, right? We can render 2 blocks on the screen. I guess, yeah, that was kind of stupid. I don't know why I did that, right? And we got a batch render test, right, where I rendered 2 blocks or 2 2D images with, you know, one being a dirt block, one being a brick block, but within one draw call, right? So I think today kind of what the idea is, dynamic geometry, if I was to guess, is maybe we're rendering like you know, maybe the ability to like modify this maybe on the fly or something. I don't know. It's kind of, maybe we're modifying this on the fly or something. I don't know, but yeah, I don't know. I you know, it could be something like that. Maybe it could be rendering different shapes or something on the fly. I have no idea, but I guess we'll see. I'm a fail in life if I compete against people like you in the job market. No, bro. That's not true, dude. That's not true at all. You'll be okay, bro. Just gotta put in that work, bro. Bro, if I was to give you any hope, dude, and I'm telling you, if I was to give you any advice, bro, just, this is specifically just like raw Leetcode, right? Like, hang on, where's my Leetcode, dude? Right. If I was to give you any advice, bro, when I first started Leetcode about like a year and a half ago, I could barely solve 2-sum, bro. So, you know, if that gives you any hope, like, that was probably, that what you just saw on stream was the first time I've ever solved a 2000 rated problem. But, you know, I could barely solve 2-sum like a year and a half ago. So, you know, you can go places, bro. You just got to keep grinding. You know, I mean, you can see my consistency, like, you know, I didn't do it every single day, right? I did it probably like 5 times a week on average, but, you know, best of luck to you too, bro. But you got it, man. Trust me. I'm telling you. Just keep grinding, and if you enjoy it, you just gotta enjoy the grind, bro. Leetcode too boring. I enjoy project more. Yeah, dude. Me too, bro. I 100% agree. I enjoy projects more too, but sadly, I feel like it's needed sometimes in the technical interviews. So, but yeah, I agree, bro. Leetcode is definitely much better. Oh, sorry. Project. Sorry, that's what I meant. It's much better. So, let's take a look here at this video.
Hey, what's up, guys? My name is Ashona. Welcome back to this batch rendering mini-series. So last time we took a look at how we could get textures into our batch.
Do some dynamic geometry today, bro.
Haven't already. And today we're going to be talking all about dynamic batching. So up until now, we've had our entire batch, our vertex buffer, kind of defined up front. All of the data that's been in it, we've defined at the beginning of our application, and all we've done every frame is just simply rendered it. We've referenced that existing data that we've already sent to the GPU, and then just told it to be rendered. We've commanded it to be rendered via a draw call. Now that's great because there are heaps of scenarios in games where we just have like this kind of static geometry blob and we just want to keep rendering that. We don't really care about being able to control it. But there are also a lot of cases in which that's just not going to cut it. We actually need to be able to, frame to frame, set the positions of all these different quads that we've grouped together into one draw call, into one batch, dynamically, and that is what today's video is about. But first, I want to thank Skillshare for sponsoring this video. So for those of you who don't know, Skillshare is an online learning community for creatives where millions come together to take the next step in their creative journey. Skillshare offers thousands of inspiring classes for creative and curious people on topics including illustration, design, photography, video, freelancing, and more. I think that pretty much all of you watching this video right now, you're people who really want to learn more, and that's exactly what Skillshare lets you do. And I love the fact that Skillshare's videos are typically so short. I mean, mine can...
Oh, bro, we got an ad, dude. What an ad.
What's this? She's opening her Fidelity app.
A new skill on Grey, and you have to type about your demonstration class in which you experience a 2 hour first of learning and export it all your video, making your batch rendering dynamic. As always, thank you to Skillshare for sponsoring this video. Okay, let's talk about dynamic batch rendering. So there are a few moving parts when it comes to making your batch rendering dynamic. In fact, there's 2 kind of main parts, and that's the vertex buffer and the index buffer. So today we're going to focus specifically on that vertex buffer. As we've seen so far in this series, when our program first starts up, that's when we create this kind of vertex buffer. But what if we didn't have to predefine all of those
shaders. Yeah. Yeah, shaders. I don't know if you're talking about shaders in my project, or I'm not sure, but yeah, dude. Shaders are dope, dude. Let's go. We're taking a look at batch, the final episode, batch rendering, dynamic geometry.
Vertices right then and there during our initialization code. What if we could somehow move that responsibility and make it something that we can actually do every frame, data that we can set every frame. That would mean that we could dynamically respond to, for example, the position of a quad or something like that, or the size of a quad, or if this quad even has to be rendered or not. It would give us tremendous power, really. And the good news, of course, is that we can do that, and it's actually pretty simple. All we really have to do is mark our vertex buffer as dynamic. That means that we can actually set the data inside that vertex buffer whenever we like. We can just simply copy bytes of memory into that vertex buffer at some kind of location. There are a few different steps involved in this, but just to quickly summarize what it is we're going to do here when we jump into the code, we're basically going to take the function that we use to actually set the data and use it only to allocate an actual buffer on our GPU that is large enough to hold all of our vertices. We're not going to set any data at all. And then later on in the actual rendering code, just before we render, we're going to come in and we're going to copy all of that data from our CPU, all of the vertex data that we have there, into OpenGL, into our GPU, so that we can then access it and render it as normal. So it's a very simple move when you think about it. We're just literally taking that block of vertices and moving them to be in that kind of rendering function that we're using that gets called every frame. But of course, by doing so, we make it dynamic, because we can now calculate that data or respond to anything really to determine what the data should be, and then upload it then and there without having to worry about any kind of predefined data whatsoever. Anyway, it's going to be a lot easier to actually understand when you see the code and when I walk you through it, so let's dive in and take a look. So this is all the code from last time, and if I launch this, we got this result. We just kind of had these two quads being rendered here with separate textures all batched together into one draw call. And now what I want to do is take you guys through what it takes to make this all dynamic. So as I mentioned, it's currently static in the sense that everything that we define for this particular batch, for this vertex buffer, it's all done like in this onAttach function. It's all kind of set in stone to be a certain value, and that's it. When we come over here into onUpdate, all we're doing here is essentially binding the textures, then binding the vertex array, and just...
Sounds interesting. Wonder how 3D programming looks like today. Yeah, bro. Me too, dude. I haven't done anything 3D before in my life, but I definitely will get to that on this channel. The goal is to finish this episode, kind of, and we're gonna start the next, probably starting tomorrow or even the following day, we're gonna start creating a 2D engine, right? I might even like figure out the name on stream today or something. Maybe I'll get Claude or something to generate me some names, bro. We can name the project the 2D engine, whatever. Kind of the goal is to use that 2D engine to then, you know, build some simple, you know, 2D game in the future. But just trying to get a really good idea about graphics programming, kind of like the GPU pipeline and all those different things. So that's kind of the goal, and then hopefully have that great foundation to then move into kind of like 3D stuff. So that's kind of what I'm most excited for. So
just issuing that draw as well. Now there are some things we can still customize, like for example these uniforms here. We can change the camera, we can change the transform of the entire batch, and we can also bind any two textures we want. So the fact that those two are currently the Cherno logo and the Hazel logo, there's nothing to stop us from flipping them or introducing another texture. We can do all of that, that's all fine. But what we can't do is change the position of one of the quads, for example, or change the size of it, or do anything like that whatsoever, because this vertex data is in fact already inside the vertex buffer, and that vertex buffer is essentially set in stone. So what we're going to do is just change all of that completely, essentially vertex data, or fine.
But what he did, he did GL bind texture unit. I don't think I did that. GL bind. GL bind texture unit. I don't remember that. I don't know if this is that he already wrote this code or GL bind texture unit. Bind an existing texture object to the specified texture unit. Okay. Interesting. I don't know. I guess let's keep watching.
Change the position of one of the quads, for example, or change the size of it, or do anything like that whatsoever, because this vertex data is in fact already inside the vertex buffer, and that vertex buffer is essentially set in stone. So what we're going to do is just change all of that completely so that every frame we actually create this vertex buffer data. And there are a few ways to actually achieve something like this, so I'm just going to show you one of the ways that I like doing it, but just keep that in mind. The idea here and the thing to really take home here is that you can dynamically change the contents of your vertex buffer, and that is how you achieve this dynamic kind of rendering. Okay, cool, let's begin. So the first thing that I'm really going to do is not worry about these vertices. I mean, they're set up pretty well here, but I'm just going to pretend that they don't exist. I'm going to just comment them out. The reason being that even though we could start with these vertices, we're probably going to want to...
Black Friday is here at Dick's. 30% off Nike, up to 40% off.
I'm getting tired, bro.
Adidas, Carhartt, and
dynamically set
It's getting
them
dark,
every
man.
frame.
There's a snowstorm outside right now. Crazy.
So this data will eventually move into the onUpdate function. What I'll do is I'll come down here into GL buffer data. This is the important kind of function that we call here, because what this does is, well, it actually does a few things. Apart from just simply setting these vertices and actually sending them to our GPU and storing them in GPU memory, it also actually allocates the buffer on our GPU that will hold all of this data. And this is really important to note, because what we can actually do is basically change how we use this function completely. Instead of actually using it to set data, we can just use it as an allocation function. And the way that we do that is, instead of supplying it with a pointer to a buffer, which is what we're doing here, we're giving it that vertices pointer, which is a float array, which is a float pointer. Instead of doing that, we can simply give it null pointer, which means we're not supplying it with any data. So then the usefulness of this function falls into this parameter, which is how much data do we want to allocate in bytes? And this is how we're going to use this function. What we're going to do is we're going to just allocate a maximum size for our vertex buffer, and then every frame we're going to kind of populate that vertex buffer with certain data and keep track of how much data we've actually populated it with. So what we need to do now is decide how many vertices essentially we can store inside our vertex buffer. Of course, arbitrarily typing in a number like 1024, meaning a kilobyte of memory, that's not really that useful, because obviously this is a vertex buffer and we want to the units that we want to use for this are vertices, because we can't have half a vertex, that's useless. So what we want to do is figure out just how big one vertex is. Now at the moment, everything is just a bunch of floats, which is kind of annoying. It's not really a really nice way of doing things at all, because just by looking at this, it's actually really hard to tell just by reading it that these three are the position, these four are the color, these two are the texture coordinate, and this is the texture ID. That kind of makes no sense. So what we would probably want to do instead is create a struct called vertex. And inside this struct, we're going to basically have the structure of each vertex. So what we'll do is we'll have 3 floats for the position, which I'll write like this. Then we'll have 4 floats for the color. Then we'll have the 2 texture coordinates. So I'll call this text coords 2. And finally, we'll have a text ID as well. Okay, so now we have a complete vertex. That basically replaces all of this, and we can actually set these up much easier now. If we want to create a new vertex, we can do something like this, and then set, for example, the position equal to whatever the position should be, without actually having to just basically have this huge row of floats, which could be interpreted anyway. Okay, cool. So now that we've got that, let's decide how many vertices we want. Well, just for this example, let's just say we want 1000 vertices. So what we'll need to do is say size of vertex times 1000. So we've basically created a vertex buffer that is capable of storing 1000 of these vertices. That is how much memory we've allocated. We don't have to store exactly 1000 or anything like that. That's just the size. That's the entire capacity of our vertex buffer. We can't exceed that, but we can definitely say that, you know, in this case, for example, we only need 8 vertices. So we can absolutely just store 8 in there if we want. And now finally, this parameter is really important. At the moment, it's set to static draw. What this is a little bit of a hint to OpenGL to how we're going to actually use this memory. So static draw means that we've kind of defined everything statically up front, and that we want to use it for drawing. So really what this is saying is it's going to act as read-only memory. We're not exactly going to write to it. However, we want to write to it every frame. So what we need to do is change this to read GL dynamic draw. So what this means is that we're going to dynamically be populating the vertex buffer, and of course we're still going to be using it for drawing. If you're still unsure as to what this actually means, then definitely consult the OpenGL documentation, which will define it more formally. Okay, cool. Down here,
yeah, I'm gonna kind of go over that. I kind of missed
we're
exactly.
exactly going to write to it. However, we want to write to it every frame. So what we need to do is change this to read GL dynamic draw. So what this means is that we're going to dynamically be populating the vertex buffer, and of course we're still going to be using it for drawing. If you're still unsure as to what this actually means, then definitely consult the OpenGL documentation, which will define it more formally. Okay, cool. Down here, this...
Let's take a look, bro, because why not? GL underscore dynamic draw. I'm just gonna take a look at this Reddit. Join me, huh? Interesting, bro. Interesting. Something wrong with my mic, bro. Hang on. Yeah, I need to get a new mic, dude. I think I have a static issue. Maybe it's like a cable issue or something, but I don't know. I don't know what it is, but type shit, bro. Anyway, we will continue with the video.
Remains exactly the same, except instead of having this 10 times float here, which is what basically one vertex is, it's 10 floats, we can simply write size of vertex, which is just going to kind of clear it up. So I'll kind of just apply that to all of these. And finally, another kind of code clarity thing you can do here is just use the offset of function here. Well, it's actually a macro that lets you figure out the byte offset of any member. So in other words, we can use this to actually get the correct offset in bytes of each one of these struct members, which are of course our vertex attributes. So I'll copy and paste this into all of these ones. So we have color, then we have text coords, then we have text ID, and I'll even do this for the first one, just in case we decide to rearrange our struct, because that means that this will always work. Because of course, if we do rearrange this, then the offset will also be rearranged here. Okay, cool. So this is looking a little bit more clear now, a little bit easier to read. None of this changes. Let's take a look at our index buffer. So what changes with our index buffer? Well, that's kind of the beauty of this. Nothing. The index buffer really shouldn't change, because what we're going to be doing is just setting this data dynamically. But the fact that to draw a quad, we need to draw index 0, 1, 2, and then 2, 3, 0, that's not going to change. It's just going to keep going in this pattern for as many quads as we decide to draw. So in other words, what we would probably want to do is, since we've marked this as 1000 vertices, which, I mean, I don't even know how many quads that is. You have to divide it by 4, so I guess 250 quads is how many we can draw with 1000 vertices inside our vertex buffer. So 250 quads, you would want enough indices for all of that to be drawable. So typically you'd set up like a for loop.
So you want to be a software engineer. Go to boot.dev, make a free account.
That would basically continue generating indices ever ascending in this pattern. So we'll take a look at that in a future video, because I really want to focus on specifically the vertex buffer here. We'll still pretend that we're drawing 2 quads, even though technically, of course, we can draw 1000 vertices. And then next video, we'll expand the index buffer and all that to take care of how to actually draw any arbitrary amount of quads, which will be quite exciting. So with that being said, if we recap what we've done, basically what we've done, apart from kind of set up a struct here to define our vertex, we've allocated enough memory for 1000 vertices. But the actual vertex buffer is still completely empty, but it's been marked as dynamic draw, meaning that we can actually populate it within our update loop every frame if we need to. So let's do exactly that. I'm going to come over here and I'm just going to make some space, because this is where we're going to actually set our dynamic vertex buffer. So what I want to do is bind the buffer the same way that I do it here. And then there are a few different ways to actually do this, but essentially what I want to do is somehow send some data into that vertex buffer. So one of the ways you can do this is by using GL map buffer. What this will do, if we actually take a look at it, here is the actual function. What this will actually do is return a void pointer to us of memory that we can actually directly write into. And when we do that and call GL unmap buffer, which is kind of the other side of this function, it will actually upload that buffer to the GPU. So that's one way of doing it. In a lot of cases though, this actually ends up being slightly slower than the method that I'm going to use. And also the method I'm going to use has the added advantage of the fact that it's supported in lower versions of OpenGL. And that is GL buffer subdata. So this is extremely similar to GL buffer data, which is what we used here to actually allocate the memory. But what it does is basically instead of doing any kind of allocation, it just simply sends that data into that buffer. So what we'll do is type GL array buffer as that first argument because that's our target. Then we'll have to specify the offset of this data. So since we want to actually copy this data into the beginning of the buffer, we'll just write 0 here because there is no offset. And then we simply need the size of the data we're copying and then a pointer to the actual data. So let's come back over here and we'll steal our vertices, and that's what we'll do. We'll just set these into our buffer. I'll just paste them over here, and then what I'll do is I'll just leave them intact for now. We'll transition them over to that vertex structure in a minute, but I can still leave them as flow vertices. The memory is identical. So we'll just say size of vertices and then finally vertices. Okay, cool. So what we've done here is effectively dynamically every frame we're now populating our vertex buffer with this vertex data. And that's it. I mean, you could unbind your buffer, but that's not strictly necessary in this case. This is how we do it. Keep in mind that we're still actually only rendering 12 indices. What we've done here is we've set up our vertex buffer dynamically, but if we come up over here into indices, we are still drawing 12 of these, meaning that, well, 12 is all we have in this case, but we're just going to be drawing index 0, 1, 2, 2, 3, 0 for the first quad, and then 4, 5, 6, 6, 7, 4 for that second quad. So no matter what, if I duplicate this data, if I do whatever I want with it, if I add more stuff, it doesn't matter because these first 0 to 7 vertices by index, that's actually what's going to get rendered because our index buffer controls what we render from within this vertex buffer, and this controls how many we actually render. Okay, so if I hit F5 to run my program here, we should get exactly the same result. And you can see we do. Okay, so what's actually changed? Well, this is done every frame now, which means we can control these values. And in fact, let's go ahead and transition them over to use our vertex struct. I'll pull this struct out and I'll just put it at the top of our file here so that the entire file can actually access this. I'll come over here and I'll make some kind of function that returns 4 vertices for us, which is what we need to actually render a quad. This is just going to be a really simple example to show how we can actually control this dynamically. So I'll return a standard array of type vertex, and of course we'll have 4 of these. I'll call this create quad, and I'll actually mark it as static. And then let's take in X and Y as arguments, meaning we can actually control the position of this quad. Then what I'll do is simply create the vertices. So I'll have my vertex V0, which is going to be my first vertex. I'm going to set the position of that equal to. Let's go ahead and just copy this stuff to begin with, because this will take a little bit of time. In fact, what I'm going to do is just fast forward through this as I copy all of this data and just simply put them into the relevant vertex. Okay, cool. So that looks pretty good to me. And then finally, I can just return V0, V1, V2, and V3 as our array. Okay, so now we have a really simple way of just getting 4 vertices and then customizing them based on these parameters. So let's actually make that happen. We'll kind of set the size of these to be 1, meaning a quad should be a 1 by 1 unit quad. And then just for simplicity's sake, we'll assume that the bottom left corner is actually kind of the origin of this quad, meaning this will simply set to be X and Y. And now this will be X plus size and just Y. This will also be X plus size. And then now we'll have Y plus size. And then over here, we'll just have X and Y plus size. Okay, cool. So now we have all of our vertex positions set up. The color we've currently hard coded to be this value, but it doesn't really matter. We're using textures now. So the other thing that I'll do is just simply take in a texture ID here. And this texture ID is what we'll actually put into this attribute over here. So we have a texture ID for all of our vertices. Okay, cool. There we go. We should now be able to use this to draw quads. So what I'll do, I'll call my create quad function, and then I'll pass in -1.5 and -0.5, which is what this used to be, of course, and then a texture ID of 0. So that's great. That's my first quad, and then my second quad is going to be at 0.5, -0.5. So we'll keep the negative 0.5 here, and we'll just change this to be 0.5. Cool, so I've got my 2 quads now. But obviously, I need to actually add them to some kind of buffer of memory that I can then give to this GL buffer subdata function. So what I'll do is keep this real simple. I'll just say auto Q0 for quad 0, auto Q1 for quad 1, and then I'll allocate enough storage for both of these quads. So in other words, I know that 2 quads are going to be 8 vertices, so we'll say vertex vertices 8, and then I'll simply mem copy all of that data here. So I'll say into vertices, I'm going to copy all of Q0.data, and that's going to be Q0.size times size of vertex. And then I'm going to do the same thing for Q1, except this is now going to be vertices plus 4, or vertices plus Q0.size if you really don't want to hard code anything. And now that we've got this, I'm just going to hide all of this data by just commenting it out. And obviously we've called it the same thing, so vertices should in fact be set here. Let's run our program and see what we get. And of course, I seem to have forgotten that arrays like this are non-assignable, so what we'll do is just go to our vertex and simply make a struct called vec3, which will be just a 3-component vector here. And then I'll do the same for vec2 and vec4. Rearrange these, and then we'll simply change this to be a vec3. We'll change this to be a vec4. This will be a vec2, and then we have a float. Obviously, in a real example, you'd probably use a math library, so you wouldn't be doing any array stuff anyway. Okay, cool. So now hopefully our code will compile. And now that it does, let's take a look at what we get. Okay, cool. So looks like we have the same result, but they have the same texture. And I guess that would be because we passed the same texture index. So we'll pass.
Interesting,
what's
bro.
going on.
Interesting stuff.
Tell me you found that cube.
a texture index of 1 into our second quad. And now we should get the exact same result as before. And you can see here it is. Pretty cool stuff. But here is where it gets cooler and we can really take advantage of this dynamic stuff. What I'm going to do is add a control to IMGUI. I'll just write IMGUI begin controls. And then we'll simply make an IMGUI control for the actual position of our quad. So we'll say drag float to quad position. We'll pass in a member variable called quad position, which we haven't made yet, and then we'll just write the speed as 0.1. So what I'll do is I'll go over here into our header file. I'll write float mquad position, and we can set it equal to -1.5, -0.5, which is what it was in the first place. And then what I'll do is I'll actually use this as the position for our first quad here. And now if I hit F5, you can see I have these controls here for this quad. And if I move this, you can see the quad actually moves. And of course, this one doesn't because we're just dynamically setting the vertices inside our vertex buffer. So now we can dynamically render our batch. And that's all there is to it. Our vertex buffer is now completely dynamic. Now there is the other...
I need to look at the difference here. Static drawing and okay, so the difference between this static draw and this dynamic draw is that it's just hints really, and it places, it seems like here that the like GL dynamic draw like hints to the GPU, you know, that this is going to change frequently, right? So it kind of optimizes it to put it in the fastest possible GPU slot for writes, apparently. But instead with static draw, since it's not going to change frequently, it's going to put it in the fastest possible GPU memory optimized for reads. There's another one called GL stream data. Doesn't really go over that much, but... Alright, let's kind of implement this, or kind of try and figure it out, right? So... let's go into our SRC here. Tests. Let's copy this. Can rename this to, where's our rename? Test. Let's call it dynamic.cpp. Include in our project. Okay, let's call this test dynamic. Let's change all this stuff, bro. Test dynamic.h. Yeah, looks good. Let's change this include here to include test dynamic.h. Okay, I think that should work. Let's run it. Okay, I don't like how this menu kind of spawns off the screen, but I guess that can be something we can fix later. So this is all working, right? Perfect. We can jump into our test menu.cpp. Let's add a button here. I'm GUI button and call it test dynamic geometry. I'm underscore current test. So you go to new test. We need to include. So I can include test dynamic.h. You test dynamic. M underscore current test, and then we pass a pointer to this. Yes. Cool. Okay. So we have our vertices here. We have our indices. Trying to think here how exactly we can convert this, right? General kind of goes over exactly what he's
This
doing.
Black Friday gift cleans
bro,
your
get
retainer
mad.
at the touch of a button. No more brushing or tablets. Over 4 years ago, our team of engineers knew there had to be a quicker, easier
Read GL dynamic draw. So what this means is that we're going to dynamically be populated as to morphing this. We can another one of these can use the struct map, actually a map of code that lets, of course, our vertex up. We're still be painting vertices. That is how much memory we've allocated. We don't have.
So he builds a struct here outside, which kind of has all our stuff. What do we have here? We have water projection, translation. Our vertices here. We got positions, text chords, and a text ID. I think he's got a little bit different. So I think we've got these 3 positions, 2 textures, and 1 texture ID. So I think the goal is here. Let's kind of put this struct outside over here. Struct the vertex. Side of this struct, we can put the position. In our case, we have 3 floats, text chords, right? We have 2, and then we got a float text ID, right? Which is just 1.
Have to store exactly 1000 or anything like that. That's
Let's see where he goes here. This here is just a hint, right? That's kind of what we learned when we actually draw. Dude, I'm getting a headache. So I think this is where we do our draw call here. Maybe not. We're looking for the GL buffer data. So that may be in something else. I think that might be in our vertex buffer here. I guess we need to open our vertex buffer. Creates the buffer, binds the buffer, sets GL buffer data. Oh, GL static draw, here we go. This is where we do it, the static draw here. So maybe we want to create a separate class here. Should technically be the same thing, but instead uses a dynamic draw. So maybe we can do that, because fuck it, why not? Let's do that. Because this is in the constructor right now, but I don't... Actually, let me see. Maybe there's a better way we can do this. Like, maybe we can add some sort of flag to this constructor here. Yeah, constructor overloading. Okay, add a second constructor. Geo enum usage. So I guess we can add like a separate constructor here. Vertex buffer dot h. Can add a vertex buffer const void pointer data unsigned int size gl enum usage. Then we can write that over here. GL. Kind of write that constructor here. Vertex buffer const void pointer data unsigned int size gl enum usage. It's gonna do the same thing, right? But this constructor here, what do you mean, bro? This is literally exactly what I'm looking for. GL enum is undefined. Hashtag include. Let's grab this garbage over here. There we go. Okay, we just include that. That should work here. So now instead here we should use GL underscore dynamic draw. Perfect. So now when we come over here, we don't need this anymore. When we come to our test here, and we actually create our vertex buffer here, we just pass in GL underscore dynamic draw. Okay, perfect. So I think that works, right?
Find everything. It's going to act as read-only memory. We're not exactly going to write to it. However, we want to write to it every frame. So what we need to do is change the relating what this is. Okay, cool. Down here, this remains exactly the same, except instead of having this 10 times float here, which is what basically one vertex is, it's 10 floats, we can simply write size of vertex, which is just
Size of vertex. So Size of vertices. In this case here, we're not going to have vertices. We're going to have a vertex, right? So maybe that's something we need to change here as well. Size of vertex. I guess we can do times 1,000 too. I'm not really 100% sure if that's... We want to pass in null pointer to this, right? Because... Let's see here, if we pass in null pointer, vertex buffer... Dude, just show me the CPP file, bro. Yeah, our size here is an unsigned int. GL buffer data. GL buffer data. GL array buffer. Size. The data. The const void data. So yeah, we pass in null pointer here. So let's go back to this. Vertex buffer. Test dynamic. So the vertices here, we pass in null pointer. Let's get rid of this test. Get rid of that. Test dynamic, we want that. Get rid of that too. Let's put the H file over here. We don't need that. Texture, go away. Basic shader 3, no thanks. Vertex array.cpp. I don't know if we... Test.h, render.h. Okay. Get rid of some of our files, dude. Okay. Where do we want to go from here? So, done the dynamic draw now. We pass the null pointer, the size of the vertex.
Gonna kind of click. What you can do here is just use the offset of function here. Well, it's actually a macro that lets you figure out the byte offset of any member. So in other words, we can use this to actually get the...
Okay, and he does this in the vertex array trib m_quad vertex buffer. So maybe that's in the VAO, I think. What G? We're looking for GL vertex trib layout.get stride offset const void pointer offset. So how are we calculating the offset here? Offset plus or equal to element.count vertex buffer element get size of type. Get size of type. That's a... Would that work though? Is that vertex buffer element is a int count normalized. Get the size of type switch statement. If it's GL float, we return 4. I don't know if that'll work. I'm not really 100% sure, but I don't know, dude. I guess it's a learning process. For now, we'll leave the offset. Honestly, I'm not sure, but so where is our VAO? This is our layout. I'm gonna leave a note. Ep31, right? Offset could be an issue. Okay.
The correct offset in bytes of each one of these struct members, which are of course our vertex attributes. So I'll copy and paste this into all of these ones. So we have color, then we have case we, then the offset will also be rearranged here. Okay, cool. So this is looking a little bit more clear now, a little bit easier to read. None of this changes. Let's take a look at our...
Let's write a note here, dynamic geometry.
index buffer. So what changed? Index buffer, the fact that to draw a quad we need to draw index 0, 1, 2 and then 2, 3, 0, that's not going to change. It's just going to keep going in this pattern for as many quads as we decide to draw. So in other words, what we would probably want to do is, since we've marked this as 1000 vertices, which, I mean, I don't even know how many quads that is. You have to divide it by 4, so I guess 250 quads is how many we can draw with 1000 vertices inside our vertex buffer. So 250 quads, you would want enough indices for all of that to be drawable. So typically you'd set up like a for loop that would basically continue generating indices ever ascending in this pattern. So we'll take a look at that in a future video because I really want to focus on specifically the vertex buffer here. We'll still pretend that we're drawing 2 quads, even though technically, of course, we can draw 1000 vertices. And then next video, we'll expand the index buffer and all of that to take care of how to actually draw any arbitrary done. Apart from kind of set up a struct here to define our vertex buffer is still completely empty, but it's been marked as dynamic draw, meaning that we can actually populate it within our update loop every frame if we need to. So let's do exactly that. I'm going to come over here and I'm just going to make some space because this is where we're going to actually set our dynamic vertex buffer. So what I want to do is bind the buffer the same way that I do it here. And then there are a few different ways to actually do this, but essentially what I want to do is somehow send some data into that vertex buffer. So one of the ways you can do this is by using GL map buffer. What this will do, if we actually take a look at it, here is the actual function. What this will actually do is return a void pointer to us of memory that we can actually directly write into. And when we do that and call GL unmap buffer, which is kind of the other side of this function, it will actually upload that buffer to the GPU. So that's one way of doing it. In a lot of cases though, this actually ends up being slightly slower than the method that I'm going to use. And also the method I'm going to use has the added advantage of the fact that it's supported in lower versions of OpenGL. And that is GL buffer subdata. So this is extremely similar to GL buffer data, which is what we used here to actually allocate the memory. But what it does is basically, instead of doing any kind of allocation, it just simply sends that data into that buffer. So what we'll do is type GL array buffer as that first argument because that's our target. Then we'll have to specify the offset of this data. So since we want to actually copy this data into the beginning of the buffer, we'll just write 0 here because there is no offset. And then we simply need the size of the data we're copying and then a pointer to the actual data. So let's come back over here and we'll steal our vertices, and that's what we'll do. We'll just set these into our buffer. I'll just paste them over here, and then what I'll do is...
So really we're moving all this into our onUpdate function. I don't know if I have an I do have an onUpdate function, so... I guess I'm moving all these vertices into here. I can move our vertices in here. What are you working on? I am literally just working on a simple, like I can show you. Just some tests, making some tests, like learning OpenGL. I have a debug menu here, some tests and stuff. You know, rendering things to the screen. You know, batch rendering, whatever. Just made some tests pretty much. I'm just trying to learn OpenGL, and I plan to kind of start a game engine tomorrow. That's kind of the goal. It's like a little project sort of thing, 2D game engine. Trying to just understand the fundamentals. So yeah, learning a little bit about batch rendering, well, dynamic batch rendering, which is a little bit confusing, but you know, we're making it work. So GL bind buffer. Goat. Car fan, dude. Let's go, dude. Type shit. Goat, bro. Goat things, dude. Trying to think about this, but I think, you know, yeah, let's open vertex buffer.h. Here we have a bind. GL bind buffer, right? That's what he's... So that's our bind, right? GL bind buffer here. Binds it to our renderer, which is GL bind buffer. It's got MScore quad VB, which I think is the same thing, right? I mean, that's
I'll just leave
VBO.
them intact for now. We'll transition them over to that vertex structure in a minute, but I can still leave them as flow.
The thing is, though, is when I dynamic .cpp. The thing is, though, is I have my struct here, but I have my, oh no, it's a unique pointer, so it should be able to work. So where do we bind our buffer? m_vertex buffer. Do we bind it anywhere? I don't think we specifically bind it. Let's bind it here. m_vertex buffer dot bind. No dot bind. I don't know why is this not working. It is a vertex buffer, so what the fuck is happening? There's no member bind. What are you talking about? Oh, there we go. It's a pointer. Whoops. Take that. We bind. GL buffer. GL buffer. Sub data. GL underscore. Let's go array buffer 0. What is he passing in here?
Vertices, the memory is identical. So we'll just say size of vertices and then finally vertices.
This may be the last ad you ever see. Because with the free ad block extension from Capital One Shopping...
Fucking ads, bro. I already watched the
Okay,
video,
cool. So
bro.
what
You're
we've
really still giving me ads, man. Size of vertices, right? And we can pass in our vertices for our fourth parameter over here. Vertices. Whoops, I can't spell vertices. No, we don't need that extra. Okay, perfect.
Here is effectively dynamically every frame we're now populating our vertex buffer with this vertex data. And that's it. I mean, you could unbind your buffer, but that's not strictly necessary in this case. This is how we do it. Keep in mind that we're still actually only rendering 12 indices. What we've done here is we've set up our vertex buffer dynamically, but if we come up over here into indices, we are still drawing 12 of these, meaning that, well, 12 is all we have in this case, but we're just going to be drawing index 0, 1, 2, 2, 3, 0 for the first quad, and then 4, 5, 6, 6, 7, 4 for that second quad. So no matter what, if I duplicate this data, if I do whatever I want with it, if I add more stuff, it doesn't matter because these first 0 to 7 vertices by index, that's actually what's going to get rendered, because our index buffer controls what we render from within this vertex buffer, and this controls how many we actually render. Okay, so if I hit F5 to run my program here, we should get exactly the same result. And you can see we do.
Okay, I'm gonna F5 run this. There's definitely gonna be an issue here for fucking sure, but... Oh. Shit, maybe not. Damn. Maybe I'm actually doing it. What the fuck? I was expecting like some fucking error here or something. Rendered. Let's try dynamic geometry. Interesting. I don't understand how we don't have any crashes, but...
Okay, so what's
interesting.
actually changed? Well, this is done every frame now, which means we can control these values. And in fact, let's go ahead and transition them over to use our vertex struct. I'll pull this struct out and I'll just put it at the top of our file here so that the entire file can actually access this. I'll come over here and I'll make some kind of function that returns 4 vertices for us, which is what we need to actually render a quad. This is just going to be a really simple example.
The start to the Minecraft project, yes sir, bro. No, not yet, actually. Sorry, I haven't done anything 3D. I'm kind of changing it up. So instead of getting straight into 3D, I think what I'm going to do is I'm going to build a 2D engine. And I think I'm going to start that tomorrow. So I've kind of got through the series now. I'm feeling pretty confident about my knowledge. So I think I'm going to start a 2D engine series, maybe work on that for a couple months and then kind of transition into 3D. And then kind of once I'm done with that, maybe build a 2D game for my engine and then you know, a quick 2D game, something simple, right? Just to kind of test it out. At least you're getting textures with half the battle, right? Yeah, dude. Yeah, textures is definitely really tough. A lot of this stuff is really tough, bro. Like, honestly, my knowledge isn't like super solidified, but I just got to keep progressing and keep you know, working at it every day. So it kind of starts clicking a little bit. But yeah, I will definitely recreate Minecraft here on this channel one day, 100%. So, you know, as I keep kind of working through my graphics journey, we will definitely get to the point. So yeah, appreciate you being here too, Crosshair Hero, dude. Thanks for joining again, bro.
To show how we can actually control this dynamically. So I'll return a standard array of type vertex, and of course we'll have 4 of these. I'll call this create quad, and I'll actually mark it as static. And then let's take in X and Y as arguments, meaning we can actually control the position of this quad.
Okay, this is where I think my fucking shit's gonna fail here, because I'm kind of confused at this part, what he's doing here when he's creating this function here. But we will go for it. Start array, vertex, create quad. I think he's using this to float X and Y to manage where it is the location of it on the screen. I think we need to include this in our .h. I think we need test dynamic here. Create quad. What is going on here? I guess static is local to the translation unit, right? So maybe we don't need that. Why the fuck is this not working then? Oh wow, this is not defined here. Identify vertex is undefined. Shit, would we just define this vertex in .h? I don't really know, to be honest. No? Did it like that? No. I don't know how to deal with this error, dude. Oh wait, no, we want to keep this here. How does he do it?
Then what I'll do is simply create the vertices. So I'll have my vertex v0, which is going to be my first vertex.
CPP. Test dynamic.cpp. Maybe we don't need this in the .h. Like if we're using static here, no? I don't know, to be honest. I have been meaning to jump in, but life keeps going on. Oh man, it's okay, bro. It's totally chilling, dude. I'm usually streaming here like 3 or 4 times a week or something, so. Okay, so struct. Okay, for starters, there should not be 2 eyes here, so let's fix that over here. Maybe we don't even need that here. Where vertex array? Go away, bro. Returns incomplete type. I don't know why I'm getting this. Do I need to put this in .h? Hang on, dude, I'm just gonna ask Gemini. I'm not really 100% sure. Where's this at? see what we're doing tonight. I think there's a contest tonight. Yeah, in 3 hours, weekly contest 478. Damn, bro, should I do it, bro? Should this be my first contest tonight, bro? I don't know. 3 fucking hours, dude. Starts in 2 hours and 41 minutes. What is it right now? 5, nearly 6. Starts at 8:30, bro. Do I go out with friends or do I do a Leetcode contest? I think I gotta go out with friends, bro. I think I gotta have a social life. Can't be doing Leetcode contests on a Saturday night, bro. That's crazy. So X-ray is a custom type. My hypothesis is that test dynamic CVP where the error is reported as missing the necessary header file to find the vertex for the critical implementation. You've pinpointed the error correctly. Okay, the cause of the error. Problem is the classic C++ header. Okay. You declare the function. Sees that the function returns a std array containing a vertex. However, at this point, the compiler has no idea what vertex is. Doesn't know where it's... So I just need to include it in my .h. So is that it? Is that all I'm missing here? Instead of in the CVP. Okay. So that's it. Okay, fair enough. Start the project today. Oh, I'm not sure. Becca. I'm not sure. I think I will. I have to think about what I want to call the. Well, let's kind of get some ideas. Let's generate some ideas, bro. Well, let's get Claude to generate us some ideas, bro. What should we call the 2D game engine? Anyone have any ideas? Maybe I call it like, give me some cool names for a 2D game engine project. I need some dope names, you know, like we gotta. Okay, these are pretty lame engine names. Inkwell, dude, that is crazy, bro. Axis engine. I don't know, anyone got some cool ideas, bro? 2D Max, pixel perfect. Dude, I Prism 2D, dude. Ember engine. Max 2D. 2D Max. 2D Max. Maybe I kind of like that. The Polipovich project. Bro, you're so funny, bro. The Polipovich project. Is there something called Max Engine 2D? Is that what you said? You said 2D Max. Max 2D. Max 2D. Max 2D engine. Let's search that. Let's see if there is a this is a game. Is there an engine? I mean, it's not like I'm gonna like release it or anything, but I'm just curious. Like Max 2D game ago, I guess. I think we might go with Max 2D. I think that's a good name. They sound like a nuclear project. Asking AI to generate names never goes well. Yeah, bro. Exactly. Yeah, I think we might go with Max 2D. I think that's what we'll go for. I guess it's kind of a generic name. I kind of want something like kind of drippy, like I don't know. Maybe what I have to think. If anyone has any good names, like DM me on Discord or something, or I don't know. We'll figure it out. So, but yeah, it's gonna be an interesting journey though. It's gonna be very interesting. It's gonna be very interesting to see where we Maxel 2D, dude. That's actually pretty sick too. I like Max 2D. Okay. Yeah, it's definitely gonna be an interesting journey with the 2D engine. It's gonna be a lot of researching. It'd probably be one of my biggest projects. It depends how deep we go with it, but I'm aiming for a simple engine. Something just to build a simple 2D game from. Kind of get that foundational knowledge. So it's definitely gonna be interesting. I'm happy to kind of like share the learning journey. I feel like I don't know. We'll kind of see where it takes us. So a lot of research, a lot of implementing things, and yeah, so should be good. But let's finish this. Let's finish this here. So I believe now our struct is here. Is this good now? Create quad here. You'll need GUI probably most likely. Yeah, I will. I'll probably make the project. I'll probably set up the project tonight or tomorrow, or kind of like lay out exactly what I'm going to include in the engine and what we're going to aim as like an MVP to include in the engine. Because I don't really want to get lost in that. You know what I mean? Like, I don't really want to get lost in, do I want to add this? Do I want to add that? Like, I want to have like a list of what we're going to implement, and we kind of tick those boxes, and like I move on. I don't want to spend fucking 5 months. I know you said you have a job lined up, right? What is it? Are you going game dev, or is it just normal software development? It's just normal software development. I'm working at a insurance company, just something local here where I live. But it's a software engineer 1 position at a local insurance company. I assume I'm going to be working on a lot of like legacy code bases. I was told that in the interview too. So, there's a lot of teams that work on new projects too. So I don't know. I'm not sure what team I'm assigned to yet. I have like it will give you good ideas. Yeah. I guess I have a week 1 on implementation. Okay. Yeah. No, I agree, Becca. But yeah, going back to the other thing, it's I have a week 1 like intro call coming up soon with my manager in about a few weeks. So I guess I'll kind of see what sort of team I'll be on. But I'm super excited though. I'm super excited to start work. I'm super excited to start my career and kind of get myself going. But I'm also gonna I plan. Once I start, my first day is January 5th, and I plan to keep streaming every night, because then I'll have a little bit more of a schedule, right? Nice, man. I have a buddy that used to work for a bank. They had to move COBOL to Python. Oh shit. Okay. That does not sound fun, bro. But who knows? Maybe it is fun. But yeah, I guess we'll see kind of what happens. I plan to stream every night though, starting January 5th. I mean, I'll stream at the same time every day now. Kind of right now, I kind of stream whenever I want because my schedule is like so inconsistent. So. But I plan to stream usually the weekdays, probably around maybe 6:30 for a couple hours, and then kind of keep working on the side project. So that's kind of the goal. And I appreciate everyone that's kind of here, kind of helping me learn these things. I mean, this stuff is hard, at least for me.
Let's go ahead and just copy this stuff to begin with, because this will take a little bit of time. In fact, what I'm going to do is just fast forward through this as I copy all of this data.
Okay, so he's putting in the data in here. Returns an incomplete type. So I think we actually have to return something here.
And just simply put them into the relevant vertex.
So he's creating 4 vertices here. So here we have 1 quad here. So we need 4 vertices as well. So I'm just going to get... I work for a nuclear plant as a dev right now, but I didn't get there until I was almost 30. So it's good you were getting started so much younger. Appreciate that, man. That must be pretty interesting working at a nuclear plant. That's pretty dope. Like, that's I've definitely never heard about that before. That's super interesting. But yeah, I'm excited, you know. Kind of excited to see kind of where my career takes me, and you know, I guess kind of what I do with my life in a way, you know. So I don't know. I just plan to, you know, keep working on stuff I enjoy. So we'll kind of just see where that takes me, I guess, you know. But yeah, I'm gonna.
Okay, cool. So that looks pretty good. 3 as our array. Focus on these
He's returning
parameters. So let's
that.
actually make by one origin of the size and just
Size.
white. Let's put all of our vertex positions set up. The color we've currently.
Okay, I'm gonna grab this code here. Let's grab this. I don't want to write this code either, so seems kind of repetitive. So let's implement the. Oh no, we have it here. We've got it in our .h. It's an addition of an object here, so just generate this. Let's get rid of this. This is the texture ID here that we're rendering, right? This is exactly what Chano is doing. For our XY here, 0.f. Our 3 vertices here, we have 2 vertices, and we have a texture ID, right? And we're returning V0, V1, V2, V3. But I think when I watch this video, these need different types.
Take
I
in
think
a texture ID here, and this texture ID is what we'll actually put into this attribute over.
Well, let's do that too. Let's put in a float texture ID.
Here, and this.
Call it text ID. Oh shit, he already did it. Okay, let's get rid of this then.
Texture ID is all of our vertices. Okay, cool. There we go. We should now be able to use this pass in -1.5 and negative.
Where is he doing this? So he's doing this in the vertices down here. So let's kind of move that code down here. So instead of this vertices, hang on. Go into how to comment. I need to start learning these shortcuts, bro. How to comment blocks in Visual Studio 22. What's a shortcut, bro? Control, comment selection, Control K. Is that what it is? Control K? Nope, that's not what it is. Shortcut. Does anyone know what the shortcut is, bro? Because I have absolutely no idea what this is. I know there's definitely a shortcut. Is it Control Shift K? Oh, that did not do anything. Okay, we'll leave that for now. Let's just Control slash. Okay, Control slash. Appreciate that. Thank you, Becca. I gotta remember these shortcuts, bro. Like, okay. So he binds the buffer. Let's create our quad. So create quad. I guess we can just. What are we passing up here? We've got -1.5, -0.5. 1.5 float. 0.5 float.
0.5, which is what this used to be, of course, and then a texture ID of 0. So that's 5. So I choose quads now, but
okay, let's pass in a texture ID here. 0.0f. What are we? Too many arguments in function call. What the fuck are you talking about? Oh shit, I didn't change my .h. Whoops. Float text ID. Okay. Create our quad. Create quad. This one is 0.5f. I give 0.5f. Pass in 1.0. For the texture ID.
obviously I need to actually add them to some kind of buffer of memory that I can then give to this GL buffer subdata function. 0 auto quads. So in other words, I know that 2 quads are going to be 8 vertices. So we'll say vertex vertices 8, and then I'll simply mem copy all of that data here. So I'll say into vertices, I'm going to copy all of q0.data, and that's going to be q0.size times size of vertex.
I feel like this is... Isn't this a C-style copy? Yeah. Interesting. Lack of type safe, unlike C++, still copy, which can leverage iterators. All right, I guess we'll just we'll just stick with what he's doing. So, grab this type like auto q0 is equal to create quad. Auto q1 is equal to create quad here. We then create our struct here, vertex, vertices. He has 8 in there, but I believe it's the size of the struct that we want here. So I think we have 6. Use buttons like home, end up page, down, etc. It's helpful. What do you mean by that, Becker? I'm not sure. I'm not sure what you mean by that, bro. I'm not sure what you're referring to. I think ours would be 6 here in this case. I think. I'm not really 100% sure what I'm doing right now, but I'm just kind of going with the flow. He mem copies all the data.
I'm going to do the same thing.
So let's mem copy this data. Mem copy vertices q0.data. q0.size times size of vertex. On your keyboard num keys, use buttons like home and up, page down. Oh shit, what do these do, bro? Are they, you're saying to like assign them to do something, or do they already do something? Ah, okay, you're talking about page up, page down. What does the home key do, bro? I'm honestly not even sure. Home key even do anything in this, or? Ah, okay. I understand. Okay. Cool. I have to get used to that, bro. Usually I don't really like use my right hand on the fucking keyboard. But I guess we gotta let's mem copy here. So q0.size times size of vertex, we copy it into vertices from vertices. q0.data, q0.size. Okay, so I guess we can copy this, change this to q1.
For q1, x0.size if you really don't want to hard code anything. And now that we've got this, I'm just going to
vertices plus q0.size, q1.data. Vertices plus q0.size, q1.data, q1.size times size of vertex. Okay, that makes sense, I think. Check Discord general chat. Okay, I'll check it right now. Let's take a look. Oh shit, dude. Thank you, bro. That's goated, dude. Thank you. Toggle line comment. I guess this just comes after time using the IDE or whatever, right? So cool. Thank you for that, bro. Really appreciate it. Let's continue.
To hide all of this data by just commenting it out, and obviously we've called it the same thing, so vertices should in fact be set here. Let's run our program and see what we get. And of course I seem to have forgotten that arrays like this are non-assignable, so what we'll do is just go to our vertex and simply make a struct called vec3, which will be just a 3-component vector here.
Okay.
And then I'll do the same for vec2 and
Oh,
vec4.
shit.
Rearrange these.
So let's create these, right? We have a vec3. I guess we can just do all of them anyway. I mean, it doesn't hurt, but let's do struct. Whoops. Struct vec2 float xy. Float xy struct vec3 float xyz. We don't even have a vec4, but I'll just add it anyway, because why not? But xy z, we need w, right? And then we make this a vec3, make this a vec2, and this just stays as a float.
These, and then we'll simply change this to be a vec3. We'll change this to be a vec4. This will be a vec2, and then we
it's Windows based, so it's probably pretty close to basic Windows shortcuts. Okay, sweet, thank you.
have a float. Obviously, in a real example, you'd probably use a math library, so you wouldn't be doing any array stuff anyway. Okay, cool. So now hopefully our code will compile, and now that it does, let's take a look at what we get. Okay, cool. So looks like.
Okay, here's the big thing. I don't think mine is gonna compile because mine is a little different to his, but I guess we'll see. Okay, so we already got some errors. Let's take a look. Error list. Okay, so we're still failing on this create quad error. Function test returns incomplete std array. I'm not familiar with that. Returns incomplete type. Returns incomplete type. How did he return this?
We have the same risk we have making
he returned this.
and the them point alpha x and b command make just like if now sometimes this is result if that no to mean but this stuff since we want to over here, and I'm just gonna make some if we need to. So let
I don't know. List initialization of an object is not allowed because the type is incomplete. Let's take a look here. Kind of look through this series where he did this function. I think he did the same thing as me. Did I get the return type wrong? Static std array. Yeah, I did the same thing. Vertex v3. Interesting. Maybe I need to like include it or something. Include array. Okay. Wait, hang on. Okay, so that fixed the issue. So I needed to include it. Now we're getting another issue here. q0.data. Why did I do q0.data here? Shouldn't this just be const void pointer source? This just be q0. Const void. This requires a destination, const void source. We have to convert this to a void pointer. We missing any? Test menu. Okay, I think everything else is fine. So maybe this is the last error here. So we have a type of a stud array for 4 vertexes. But what do we want to do with this here? This needs to be a const void pointer, but I'm not sure kind of what to do here, to be honest. Does anyone know kind of what I should do here? I don't know kind of what he did, to be honest. Let's see here. He did the same thing. q0.data. Oh, it's a function, bro. That's why. Bro. Oh my god. Okay. q0.data. Okay, it's a function here that returns a pointer. Okay. Okay, so that's my issue. Okay, runtime check. Vertices was corrupted. Okay, I don't know what that means. Runtime check failure to stack around variable vertices was corrupted. Test. Jeez, man, how long have I been streaming for, dude? 2.5 hours, man. Boom, 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 boom. I don't know really what my error is here, but let's kind of take a look. Did you have a good Thanksgiving? Yeah, man, I did. Q1 was corrupted. Yeah, I did, man. I went to my girlfriend's house in up in Chicago, so that was a good time. Took a little bit of a break. That was a nice little 2-day break. So I had a really good time. But yeah, what about you, man? How was your Thanksgiving? Was it good? Its classic sound of a buffer overflow. It's some averaging other days on the stack. While we're looking at the on update function versus to find the code is technically safe, even if it's not dynamic. So I think, okay, so the error is because my structure is incorrect. Nice, man. I had a good one on Marriott, so it always comes with 2 days of eating crazy, and I'm feeling it. Yeah, bro. 2 days of eating crazy. I didn't even, honestly, I didn't even eat that much, bro. Like, I don't know. I have to really force myself to eat. I'm trying to put on weight, so I've been like hitting the gym. I've been hitting the gym like 6 months, dude. My strength has got insane. Put on a lot of muscle. I used to be, well, I still am, but I used to be like really, really scrawny. I'm a really tall guy, so I'm like 6'3", but I weighed like 165 pounds at 6'3", so like I was really skinny, but now I weigh about 185 now after about 6 months of lifting, so I've got a lot bigger, put on some mass, so but yeah, I think I'm probably gonna end the stream here. I appreciate everyone watching. I'm gonna kind of fix this bug, but I'm gonna kind of make something to eat. I haven't had anything to eat, so I'm actually kind of hungry right now. But yeah, I appreciate everyone watching. We kind of pretty much got through this here. So
Like button, leave a comment.
Yeah, so we officially pretty much finished the series. I need to get back to the gym grind. I'm 6'2" and I'm 260. It's okay, man. It just takes, it's hard, man, sometimes. Especially, it's going to be hard for me when I start working again, dude. Start working full time. That shit's tough. You watch soccer? Not a lot. I played tennis in university, in college, here in the US. But yeah, I do watch soccer, like a little bit. I'm not like a, fan of any specific team or anything, but like I keep up with like La Liga and, the Premier League and all the different players. So a little bit, yeah. I like NFL mostly, but yeah. But yeah, appreciate you guys watching. If you guys are here, you guys should follow my GitHub. I would really appreciate that. Make me look better than what I am. Everything's in the description. It's crazy how Sui would be the first job replaced by Gen AI. I honestly don't think that's true, but appreciate that comment. But that's definitely not true, but it's okay. But yeah, appreciate you guys watching. You guys should follow my GitHub if you want to. Also, my Discord's in the description. You guys should join too. I'll probably be streaming again tomorrow. So, well, I will be streaming again tomorrow. We're going to start the game engine tomorrow. So, should be pretty fun. But yeah, appreciate all the love and appreciate everyone watching. Peace, guys. Yeah, exactly, Becca, lol.